So hi everyone, good afternoon. I hope you all had your lunch. Yeah, so today we'll be talking about the rest of the OOPS and NumPy module, NumPy library. Let's just wait for maybe 2 more minutes. Let's see how many people are coming. Right now it's 2:08. Let's just wait till 2:10 or 2:11 until let's see how much people are coming. Then let's start the session. I hope you all can see my screen right now. Can someone verify if you can see my screen? Maybe in a message or raise your hands. Okay, let's get going. So yeah, today we'll start from the oops part where we left. Before that, I would like to brush up a bit what we did discuss yesterday. Yesterday we basically discussed the basic concept of oops, right? Whatever is there in oops, sorry, how oops, how do you encapsulate data, and how do make a structure out of different attributes of your data. Right? That's what we discussed yesterday. As you can see, these are three types of building blocks, which is red Legos is your name, or yellow Legos is your age, and blue Legos is your pay. And we make a structure out of it with the help of OOPS. Right. So this is OOPS as a basic simple idea. Right. And then we made a class to yeah. So and then we made a class to encapsulate the data, right? So we initialize these are the parameters. We are having name, age, and pay, and we're initializing to the class name employee. Now every time we instantiate this class with a variable emp1, this is an instance or an object. So every time we make an object, we get every this instance can access all these attributes of the class, right? So this instance emp1 will be initiated with jram, sorry, jr, and the age as 21 and pay as 2000. So he or she will be having these attributes, and as well as email, description, apply raise, and as well as the raise method, the raise amount methods, the class methods, right? So this was the basic class and oops, right? So today we'll be discussing about inheritance and polymorphism. So what is inheritance? Inheritance is basically like if you can inherit from some other class, right? Here, employee. Anyone can be an employee, right? Here, suppose let's say a developer. A developer is an employee. A manager is an employee, or the recipient is an employee, or let's say a sweeper in the company that is also an employee. So everyone, in order for everyone, if you need to make a separate if I need to encapsulate the data, such as the name, age, pay, I can't just keep making new classes for everyone, right? I can't just tell class developer, then instantiate their name, age, pay, and for manager, I can't just be doing age, name, pay, all these things again and again, right? So that's why we bring in the concept of inheritance. Like now, there are different. This is the example of inheritance, and in which human is a class, right? Your father and your mom is a subclass of the humans. They are both inheriting the basic DNA sequence or characteristics that is common in all humans, right? And then you're the son, or maybe you're the daughter, right? You're inheriting the characteristics or the genes on DNA sequence from your mom. Okay, and your parents, basically both your parents. This is inheritance, the basic idea of inheritance. I hope you all have understood what is inheritance. If any new people are there, I hope you have understood inheritance. Raise your hand if you have understood inheritance. Okay, I take it as a yes, you have understood inheritance, and let's move on. So there are different types of inheritance. First, let's see single inheritance. In this type of inheritance, let's say class A is the superclass. Let's say A is your father, okay, and B is you. You're the son. I'm the son of my father. I will inherit some DNA sequence, some characteristics, even let's say some property or anything, right? So this is single type of inheritance, and we call it single inheritance, where one class, the subclass, is inheriting from the parent class. Okay, the terminology in inheritance is always parent class and subclass, right? Every class is like that. Now let's go on to the hierarchical inheritance. Let's say class A is my father, right? He has me, a son, class B, and class C is my brother. Class D, let's say it's my sister, right? We all get some share of his DNA. We all inherited some of his characteristics, some DNA, and some property as well. So this is a hierarchical inheritance, right? One parent you can form multiple subclasses can inherit from one parent or multiple parents. That is hierarchical inheritance. Now let's go on to multi-level inheritance. Let's assume class A is a superclass and class B is a subclass, and subclass of class B is class C. Are you getting it? For class C, the superclass will be class B, and for class B, the superclass will be class A. In real life, let's equate it to it. So let's say class A is your grandfather and class B is your father. Your father would have inherited something from your grandfather, right? And you will obviously inherit something from your father. So this is multi-level inheritance. Okay. Now let's move on to multiple inheritances, right? In multiple inheritance, how it goes like, let's say this is your father's side. Like I'm giving so much example of family related because that's easier to understand, right? So let's say this is your father. You will obviously inherit, let's say, and this is you, and this is your mother. Class B is your mother. You will obviously inherit some characteristics and DNA sequence and whatever extra things from your both of your parents, right? So this is multiple inheritance. But where in other cases, you're just inheriting from one group. You're inheriting from one group, as you can see here. You're just inheriting from one parent class. But here you'll be inheriting from two or more parent classes. Basically, that is multiple inheritance. Now let's move on to hybrid inheritance. In hybrid inheritance, it's a combination of hierarchical inheritance and multiple inheritance, as you can see. Here, multiple subclasses can be inheriting from a parent class, right? And in multiple inheritance, a subclass can be inheriting from multiple parents, right? We can equal this to this type of inheritance, where humans is a ultimate superclass, right? Ultimate parent class. Every human will have some type of DNA sequence which is common in everyone. Let's say, and the dad inherits some kind of sequence and characteristics from different human class, and your mother obviously inherits some characteristics from the human class, and you being the son, you inherit some properties from your father and mother. Okay, so this from here to here, if you draw the line, it will be multiple inheritance, inheriting from different parents, and from here to here, it will be hierarchical, right? So it's a mixture of both, and that is hybrid inheritance. Now let's try to implement with code. So as you have seen here, the employee, and I've actually mentioned it before. For each developer and any other role, we would not be happy to make this class again and again, right? For each developer, I wouldn't be making this. I wouldn't making this constructor again and initiating their properties, saying his name is this, and age is this, pay is this, his email is this thing, his description is this thing, and if he wants to apply a raise for that person, it's this method, and if you want to change that what is that called, incrementing value or the raise amount, you would have to use a class method. I can't be using the same thing over and over again. So what we do is we inherit this employee class. Okay. Yeah. So now we come on to the class developer, right? We come to the developer class. In this developer class, I'm writing class developer, and then I'm putting employee. Employee is nothing but the same class. This is the employee class, right? We are inheriting from employee. So we mentioned this is a syntax actually. So we put an employee here, and then we instantiate it, right? So now self is a developer, right? And name, age, pay, and we have added an extra attribute called language or a parameter in this case. Okay, so here I'm using super dot init method to initialize the attributes, right? If I use super dot, where do you think this will go? Super dot reference to this employee class, right? So here it actually becomes like in the employee class use this init method to initialize these variables, right? So here if I use super dot init and the name, age, pay, it will just refer to that these line of codes wherein the developer, the self is a developer in that case, he or she will be initiating with instantiating with the name, age, pay, right? So in this code we have actually instantiated the name, age, and pay, and then we would like to obviously pass on the language they're working in. So we'll do self dot land is equal to land, right? I'll actually run this one second. Yeah, so land. So and then we actually make a data. Employee 3 is equal to data, sorry, developer with the name and age and pay. Let's say he's getting 2000 and is using Python, right? And I'll print the data here. First print employee 3, right? It will give you the object that is created from the developer class. This is the developer class and it's saying the where it's present, right? And now I'm able to access the email. But you may ask, here we have never even here we have not even mentioned the self.email. How are we getting email? And here dot description. Here we have not mentioned description method. How are we able to access the description method? And LAN, obviously this is a self.lan, so we're able to get the language Python. So let's come back to the dot email and dot description part. This dot email and dot description part, as you have seen here, we have inherited from the employee class, right? So in employee class there is this self.email is equal to self.name plus @gmail.com, and we have also implemented a method here called description where it returns the description of the employee that is working in. So in this we are able to return self.name plus is plus string of self.age plus years old plus string of self.pay. Here we use string because even though Python automatically gives its data types, but in this case when we are passing in the parameters, we are passing in it as int, right? These are int. We are not passing it as string, and so it can't actually it can't concatenate with strings, right? The int can't concatenate with strings. Strings can only concatenate with strings, right? So we have to pass in these parameters as in strings. Okay, this is the basic things. So now the every object we create from the developer class will be able to access the name, age, pay, email, description, apply raise, and also will be able to change the raise amount, right? Yeah, and so this happens. And now let's try out some other different type of inheritance. Now I make a manager class. Okay, in manager class I'm using the same init method, self, name, age, pay, and I'm also passing employees, creating it as none. I'm using the same super dot init to initialize the parameters. Same again here, super refers to employee class, right? This is the employee class and super refers to the employee class, right? So now this is the basic thing. Others all are just additional, sorry, this total is a basic thing, right? Others all are just methods. This is all you have to understand. Yeah. So one more thing is that you shouldn't pass the mutable data types as this thing as arguments, right? Next, this is the main part of manager class, right? In manager class, we're basically inheriting from employee, and we're instantiating it name, age, pay, and we're doing the basic another parameter we're putting in, and we're checking if it is none, meaning if that field is empty, we are making a list. As we have studied yesterday, what is list? You should be knowing by now what is list, and we're making an empty list, right? If this employee if in this employee field it's not none, we are adding that employees to the employees, right? Next, yeah. So let's just check this out. Here we are using dev1, dev2, dev3, three objects. We're making three objects from the developer class named Rajesh, sorry, Raj 21 and the salary, and the language uses C. And then dev2 from the developer class Rajesh as age is 23 and so on. So uh, what's that called? Salary and Java, and dev3 obviously with the developer class. And then this is how we are instantiating the sorry this is how we are making an instance of the manager class, right? So as you can see here, we have mentioned it as a list, right? So we need to pass in the list. So let's say manager's name, his age, and his salary, and I'm passing in the and I'm passing in the list. So I'm basically passing in the objects of developer. You guys are understanding? I'm basically passing the objects of these developers. As in, now I bring to a stage where manager is a parent class, right? It also has control of developer class, right? Yeah. So I'm passing in these two objects inside this manager, right? So now I'll try to print my employees, right? Now as I passed in dev1 and dev2, and in this print method, okay, let me just explain you these methods before we move forward. In this method, we actually have we have defined an add employee method in which we have simply use a if statement. If that employee, the employee that we're going to pass in, let's say the dev4, if the dev4 is not there in our employees is our list, right? If the dev4 object is not there in our employee list, we are going to append that employee. So now our list employees will have dev1, dev2, and dev4, right? And in order to remove our employees, we are using a remove employee method, in which again we are taking in the parameter of emp, which is another object of the developer class, right? And then we are just checking if that object is there, then just remove it, dot remove. You know, yesterday we discussed, as we discussed in the list methods, dot remove and dot append and all those things. I hope you guys remember. We are just removing that particular developer object, the object of the developer class. And else if he's not there in that, we're just telling that developer object, sorry, the object of the developer class is not found. Simple. And then we come on to the then we move on to the print employees, to print all the employees that are under the manager, right? So here we're just using the employee object, and we're checking in our employee list, self.employees. This produces a list of all the objects of the developer class, right? And then we're just printing the employee dot description. As you know, employee, if a person, let's say any object, if that object is instantiated with the developer class, he or she will be able to, that object will be able to access all the methods and every attributes of that parent class. That's how we have defined it here. As you can see, description method is there in employee class, and thus emp dot description will be accessed by the developer. Yeah. So and then we just try to print it. As you can see, we are able to print it, and then we're trying to remove it. Remove dev2. I don't like Rajesh. Let's say Raj is not performing well, and I just try to remove it. This loop runs in, and then we're able to remove him. The same way we can just add him and also print the same thing. Now dev3 has been added here, and we're able to access the dot description method of this developer. Now let's go into the polymorphism. Polymorphism is also an important part of the OOPS concept. Yeah. So in this concept, actually, it's like a single method can be overloaded and can be used for in different types of ways, right? Let's say calculate is a function, right? A calculator will also do the same work as a calculator. Sorry. Let's get clear. A calculator will do the same function to calculate something. Let's say a plus b. Sorry, let's say 5 plus 5. The calculator will calculate it and will give you 5. Right. And this function can be overloaded and be used by a computer. Let's say these all are like classes. Okay. For example, I'm just and calculate is a method. Okay. Human can use this calculate method to make this some calculations, right? 5 plus 5 is equal to 10. Calculator can also use this method to give a result of 5 plus 5 is equal to 10. Computers can also use this method to give a result of 5 plus 5 is equal to 10. Right. So polymorphism is basically like same methods can take different forms to give outputs. Right. I'll give an example. So let's say these three birds are there. These three birds will obviously be produced by same kind of, sorry, not same kind of parents, same species of parents, right? Sorry, same species of birds, right? But as you see, these three birds, even though they have the same body structure, same beaks, but then they are different. Their color is different, right? So this is polymorphism. I hope you guys are getting it. Yeah. So let's just see a simple, easy example. This is the parent class called class animal, and I'm making a method, a def speak, okay, and self. I'm passing the self as a argument. Sorry, I'm passing it itself, and I'm leaving it pass. Okay. Now let's say animal, right? So class dog is an animal. I'm making a class as dog, and I'm inheriting from the parent class of animal, right? And now here it was pass, right? And I'm overloading and I'm returning wolf. The same thing I'm doing with cat. I'm inheriting from the animal class and I'm overloading with meow. Do you see this is not actually getting conflicted? Right. So if I run this, there won't be any conflict. Why do you think there's no conflict? It's because of the polymorphism, and this basically comes under hierarchical inheritance. So animal is a superclass. It has a method called speak. Dog is also able to use that speak, and then cat is also able to use that speak. Right. The same method which is there in the parent class. So that is exactly what polymorphism does. It takes in the same method, it overloads the method to produce different types of outputs. Right. This here dog inherits from animal. It takes in a method called speak, and it is overloading with and it's overloading and passing woof, and it's returning woof, right? The cat is returning meow. And now let's make a simple function to access these things. And in the function I'm just make I'm giving a variable of animal, and I'm returning animal dot speak. All right. So first, before passing this thing, I'll make a object of the dog and cat class. Right. Dog I'm instantiating with the dog class, and cat becomes the instance of the cat class. And I'm passing in the function. These objects, I'm passing in the objects as a function. Normally, if you just pass in dog or cat, it won't work because it won't know for what it's an object, right? You can normally, if you write this function without having an object of a class, you won't be able to access these methods, right? Because it's just a variable, it's not an object. But in this case, dog is an object of the dog class and cat is the object of the cat class, and that's why you're able to access it. And it's printing woof for dog class and meow for object of cat class, right? So this is polymorphism and inheritance in basic terms, right? So this covers a whole oops concept. Let's actually brush it up within like 5 minutes easily. So this has been discussed, and then basically oops covers from encapsulation, abstraction, inheritance, and polymorphism. Yesterday we discussed about encapsulation and abstraction, these two pillars, and today we have discussed these two pillars or principles of oops, right? And yesterday we basically discussed about the class variable. This is the class variable raise amount, and this is the class method. Class methods can be used to change the class variables or to make changes in the class the class of the to make any changes in the class methods or class variables, right? Yeah. And then class variables are just to be used in the class, because as we have seen yesterday, here we could have simply wrote comma amt and changed it, but we don't want to do that. So we'll just make class variable instead of making a variable for objects or instance, right? Why do we make that variables? For encapsulation, so that everyone gets the same thing, right? So that your attribute gets encapsulated. Yeah. An abstraction part is the same thing. Like you can get dot description. If I just want to describe the employee too, instead of asking the sole details, I can just do that. As you can see, Ram is 32 years old and gets 3,000 rupees. This was the basic thing what we discussed yesterday, and today we have discussed about inheritance and polymorphism. In inheritance, we have discussed about 5 types: single inheritance, hierarchical inheritance, multi-level inheritance, multiple inheritance, and hybrid inheritance. And we have also discussed how objects are being passed inside another classes, as we have seen in manager, where it has taken the developer classes objects, and we're able to access the objects of developer class and in the methods of developer class, which is inherited from the employee class. Hope you guys understood inheritance. Yeah. And then polymorphism, in which a single method or a single process can be used by multiple classes or multiple classes to be overloaded and give different outputs, based on the class or data types. All right. And here is the same. Speak method is from the parent class animal, where in dog class the speak method is being overridden, and cat class the speak method is being overridden. And then we actually make a object, and we pass in that object to the function, and the function is basically utilizing the dot speak. This will return the animal. Let's say here, if we pass in dog, it goes to the dog dot speak. It literally becomes like the object of this class, right? The object of this class dot speak. So it returns woof. Hope you have understood. The similar way, a cat also. Cat is an object of the cat class, and if you pass in cat to this function, instead of animal, it takes in as cat. It goes to the cat class, and then cat class, it goes to cat dot speak. It returns meow and prints meow. Simple. So this was the basic OOPS concept, which would be requiring for any Python related development, or let's say even artificial intelligence, machine learning, and data science. Without OOPS concept, it will be really difficult for you guys. So I hope you guys have understood OOPS concept very well. So let's, if you're okay with it, let's move on to NumPy. Are everyone okay with it? Thank you, Mohitram. Thank you, Karthik. Let's move on to NumPy. Yeah. So yeah, about NumPy. As yesterday we had discussed a simple hint of NumPy, and from Yashwant, our teammate Yashwant, who has discussed a simple intro of NumPy. Let's start with NumPy. What is NumPy actually? NumPy is a library used for computing numbers, or you can say NumPy is a library used for numerical computation, right? It provides support for large multidimensional arrays and matrices along with their mathematical functions to operate these arrays efficiently. You see, every data set in our data science or any machine learning part, if you see any data set, they always come in the form of arrays, right? And in order to handle those arrays, we need a strong we can't just use list, because lists are slower, which we'll discuss below. Lists are not reliable, right? Because it's slow, and lists don't have continuous memory allocation, right? So we need a proper way to handle and access those heavy data sets that we are going to operate on data science and machine learning roles. All right. So that's why NumPy comes into play, right? NumPy is basically handled. NumPy basically takes care of the linear algebra part and all those mathematical terms, right? And statistics and all. Yeah. So NumPy is basically used for numerical computations, right? So let's start with installation of NumPy. So How many guys are actually new to NumPy here and never installed NumPy before? Can you just raise your hands to just get a number? Okay, Divyanshu and Sneha. So for NumPy, you just use pip install NumPy in your terminal. Like, let me just wait. Uh, yeah, so now you'll be able to access my, view my entire screen. So let's just go to Python terminal. Let's say pip install NumPy. This would be the command to install NumPy. Right. For me, it says requirement already satisfied NumPy NC. So for you guys, if you have installed NumPy, this will be the command. If you guys are using, let's say, Mac, right? If you guys are using Mac, the command will be pip3 install NumPy. Obviously, for me, it'll return some error because I don't use a Mac. I'm using Windows 11. Yeah, but still it tells it's okay, it's running. Okay, good. Yeah, so that was the basic of installing NumPy. You can actually try it out after the session or even during the session because I'll be going pretty slow for NumPy. Yeah, and then how do you check if NumPy is actually installed? You go and type this command pip show NumPy. Let's check it out. Pip show NumPy. Yeah, so I get the whole bundle of NumPy which is installed, and I also get the name, version, summary, and home page from where I've installed it, and all the things. The basic data of NumPy, right? Yeah. So let's start with NumPy, right? So for importing NumPy, we just import. We just type in import and NumPy, which is also going to work, right? This is also okay. Double P, sorry, single P. We can also type in import NumPy, which is also going to work, but then we can't just be typing numpy.version and numpy.arrays basically again and again. So we just use a shorthand representation. We just make a short form as np. So whenever you have bigger frameworks, bigger libraries like matplotlib, which is so big, right? You can't just keep on typing matplotlib every time. So you just use a short form like mtb, like that, matplotlib mlb, something like that. So you can, this thing you can make it as let's say even some more smaller name, let's say AB. It will still work because it's just taking it. It is just assigning a short name for this whatever you are giving, right? You know how in your homes, if your names are so big, your parents just give you smaller, cuter, easy names so that they can remember you guys. I don't know why. Yeah, so it's basically that. Yeah, so we have imported numpy.np, sorry, numpy as np, and then we're printing np.version to get the version, right? So our installed version is 1.25.2, and this is the way how you make an np array, right? This is the way how you make an np array. 1 2 3 4, but in the list, do you guys remember, as you guys remember, let's say, oh god, let's say my list is equal to 1 2 3, and then I'm gonna print my list. Yeah, it's still the same thing, 1 2 3. It prints. So this is the way how you'll you know make a np array using numpy, and this is how we'll do a list, even though both are literally the same thing. And now we'll discuss why we use numpy array instead of lists, right? NumPy is faster because NumPy uses fixed data types, right? So basically in list, let's say green boxes or strings, okay? Like yesterday we have, as we have implemented, the list can have multiple data types, right? For let's say list element 1, 0 is having integer 1, okay? And list element at index 1 is having something like Jairam. Let's say the list goes like, yeah, so here I can declare a list saying Jaya and then comma 1 comma, oh god, yeah, comma Ram comma, and the list will still work, right? Yeah, so the list is still working. But then in case of numpy.arrays, it won't allow different data types. You can't just put Jaya and which is a string and one which is an int and again a string. It basically enforces a single data types, right? So let's just write out, let's say Ram. It'll give an error. Oh god. Okay, yeah, whatever. The NumPy has fixed data types and therefore it does not read the type of each elements in the list or arrays. Yeah, basically. It doesn't have to read the data types. Oh yeah, it doesn't read the data, but this is also possible, guys. It doesn't read it. It always takes it everything as string. Since the first one is string, it allocates everything as string, as you can see here. Yeah. So, and this is the case of NumPy, right? You can have the same thing like here I mentioned Ram. So it went to Ram. It's all it the first element is string. So it's just allocating everything as string. It's calling everything as string. But whereas you see in list, it does not do that, right? It's going to the first one. It's checking the first one. Let's say it's a string. So but still it goes second data type. It checks its data type and then puts that in, which is the automatic. Automatically it assigns the data types, right? So it passes in it as int, right? So in NumPy, it does not check every time. For the first one, it checked, so it automatically assigned everything, right? But for list, it checks each and every time. For element 0, it goes to Jaya. Sorry, it goes to here and it checks it's a string. So it marks the element 0 as a string. Let's just check it out. Print type of my list. It became new list. My list 0. Yeah, so it's a string, right? So, but let's pass an array of 1. Yeah, so it went as numpy.string. Even though here we passed it as an int, it took it as numpy.string because the first one it saw it as a string and it went on following strings, right? And next one, numpy uses continuous memory allocations. As you studied in C, every data type uses continuous allocation of memory, wherein first let's say for numbers for 4 bytes, it takes let's say 2004, then 2008, 2012, it keeps on going like that. But list is not like that. Let's say here 1 is there. It's due to these things, data type difference, right? Let's say first one was Jaya and second element was int. First one was string, second element was int. So it stores this in another different locations and next one in different location and like that it keeps on going. So every time you call a list, it needs to map from that stored spot and returns the same uh, list, right? So that's why it takes longer for list to it takes longer to access a list than a numpy or make any operations in list than numpy. Numpy works with SIMD vector processing, where yeah, basic before that numpy just uses continuous memory allocation, right? So let's say an element one's address will obviously be, if you're using 4 bytes, let's say 2000, elements 1 address is at 2000, elements 2 this address will be at 2004, 2008, 2012, next line it keeps on going like that way. Yeah, so this is numpy, which uses contiguous memory allocation, and its benefits are it has effective cache utilization, and it uses SIMD vector processing, right? Basically, what is SIMD? SIMD is nothing but simple instruction multiple data, right? So basically the SIMD simple instructions multiple data vector processing is a parallel process that runs the same operation or instructions over multiple data sets simultaneously. Yeah, so before going further, I'll just give an example of numpy and lists. Let's say mera list is equal to 1 comma, oh god, 1 comma 2 comma 3, right? No, mera list is not good. Let's say list 1 list 2. List 1 is equal to this thing, and list 2 is equal to 1. So let's say 4 comma 5 comma 6, right? And list 3 is equal to list 1 plus list 2. Now let's make two NP arrays, right? Is equal to np dot array 1 comma 2 comma 3. Array 2 is equal to np dot array 4 comma 5 comma 6, and then arr is equal to array 1 plus array 2, right? Oh god, print list 3 as well as print arr. So what do you guys think here? List 1 plus list 2, as we have seen yesterday, which does list concatenation, because it does not use a SIMD, right? But then what do you think for NumPy it will happen? Do you think it will concatenate, or what do you think is going to happen due to the SIMD? The simple instructions multiple data, where it uses parallel processing to perform the same operations on everything. So yeah, let's just check it out. As you've seen here in the list, it has basically concatenated two lists, right? I've passed in a list 3 is equal to list 1 plus list 2, so it concatenated two lists, and it's providing me the concatenated version of list 3 consists of list 1 plus list 2. But due to this SIMD, right, which does parallel processing to do same operations in multiple datasets, which literally means if I go in here and I'm telling plus array 2, right, it is basically doing addition of these two operators. Are you guys understanding? So the same thing can be done for multiplication as well. Yeah, so due to this SIMD, it basically does the operations. It does not do concatenate. For concatenate, obviously you can use np.concatenate and the two strings you can pass in. That we'll discuss later on down below. Yeah, so this is basically the difference between lists and NumPy arrays, right? NP arrays. This is important because as you can see in these cases, this is basically how NumPy is faster and effective than your very not so fast lists, right? And that's why industry uses NumPy library to handle any data sets and to perform any mathematical operations, right? So now let's go to ND arrays, which is n-dimensional arrays. So this is a single dimension array, array 1 to 3, and 2D arrays, which is array 1 to 3, comma, and then again you're making a bracket and you're passing an array 1 to 3 and 1 to 3 again, and 3D arrays. 3D arrays, it might be a new topic for you guys. So yeah, in NumPy actually we can have 3D arrays. 3D arrays you can have 3D arrays basically. In this, you'll have the first phase, red. Let's say red is the first phase, and green is the second phase, and blue is the third phase. And here we'll have three operations. Let's say x, y, z axis. So on x-axis we'll have the rows, and y-axis will have the columns, and z-axis will have the phases: red phase, green phase, and blue phase. This is basically 3D arrays, right? So now here I have implemented. I have already. Try like coded some arrays. Yeah, so num1 consists of a single array, simple 1D array, and next num2 consists of a 2D array because two dimensions. Num3 consists of 3D arrays, which is 1 to 3 and 4, 5, 6 and 7, 8, 9. Even though it sounds like three this thing, it actually means 3 rows and 3 columns, right? And I'm passing it its data type. This we'll discuss later as we go down, right? And then this is how I'm passing the 3D array. I could have written it like this, but then I've basically kept it down for you guys to understand, right? So here, these two, this is a 2D array consisting of 2v2 matrix, 2v3 matrix, right? Like 2 rows and 3 columns, right? And this is another 2D array consisting of 2v3 matrix again, 2 rows and 3 columns, right? So yeah, and this is how we declare a 3D array. You can keep on going You can keep on going comma and be adding an array like the same 2D arrays. 3D arrays is nothing but a array of 2D arrays basically. If you want to simplify it, 3D arrays is nothing but an array of 2D arrays, because this is a 2D array 1 to 3, and again the green is also a 2D array, blue is also a 2D array. So this is an array of 2D arrays, right? So we'll go to basic NP array operations, right? So now let's try to print to get the dimension of the array. Let's say num1. I want to get the num1's dimension, so I'll just do n dimension. This is the what do you say? This is the parameter, sorry, the data type to get the dimension. So if you do num.1, num.ndim, ndim literally means n dimensions. If I pass in, let's say 3D, it'll give me the dimension of 3. And if I pass in just 3, oh god, yeah, and it gives me dimension as 2, because num3 is a 2D array and num3D is a 3D array, right? And now let's get the shape of the this thing array. Print num2 dot shape. It gives me 2, 3. Why does it give me 2, 3? Because it has 2 rows and 3 columns, right? You're understanding? Same thing if I do for 3, it will give me the shape 3, 3. It has 3 rows and 3 columns exactly. And for let's say 3D array, it gives me 2, 2, 3. Let me just explain this easier, sorry, in hand before. 2, 2, 3. What does it mean actually? It means that there is 2 phases, right? Here, let's say 2, 2, 3. Let's say I'm taking only red and green, right? So there is 2 phases. First phase is red and second phase is green, right? So 2, 2, 3 literally means there is 2 phases, red and green, and there is 2 rows and 3 columns. Like here, 2 rows, 3 columns. 1, 2, 3, 1, 2, 3. That's 3 columns. That is basically the NP dot shape. And if I want to get the data type, alright, what is a data type? How many bits are used in that array, right, for each element? Right, so okay, and this is and print num2 dot d type. Yeah, so num2 uses 64 bits, right? So it is each item size will be 8 bits, correct? Because 1 byte is 8 bits, so in vice versa. And now let's get item size, right? So let's just print it out. Print let's say num2 dot print, sorry, item size. As you can see, it's 8. Here we got the data type of each element, which is 64 bits, right? So we're getting 8 bytes. And now I'll just show you the num3 why I've declared it as int 16. Int 16 means each data type is each element uses 2 bytes, 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 big B, right? So, and let's just check it out here. Num3, yeah, as you can see, it's 2 bytes, right? So if you can use 16 bytes, 16 bits, if you can mention every element, every arrays with 16 bits, which is the least, or you can even mention it as 1 byte with int 8. Int 8 is not possible, I guess. Yeah, but still 16. Why can't we just use it for every arrays, right? Like here, we can just give a data type of int 16 or int 32. Why do we always, why is it defaultly int 68, right? It's because in 68 we can only represent from minus 32,000 to positive 32,000, which you have studied in your CA, I guess. Yeah. If the data in that data set exceeds this thing, right, then we'll have a problem. A memory overflow will happen. That will be a problem, right? And also, why don't we use this int 16? Because it's a lower data, it's lower memory, right? So not lower memory storage. Why don't we use data, sorry, int 16 is because modern hardware are optimized for N64, right? And when we use N16, we may have some optimization problems. That's why we don't use N16 and we always stick to N64, 8 bytes, right? This is basically for the total size of the array, NP array, right? So I'll just print. No, let's just print num3 dot size into. Let's just print num3 dot size first. You're getting 9 because there is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are there, so you're getting 9. And then to get the total size with the memory, you're just doing num3 multiplying with the item size. This is the item size. Item size is for each byte, how much memory it actually takes, right? So item size, yeah, it returns 18. So 9 into 2 is 18. It returns that. Yeah, and then we move on to the indexing part. I'll just show you for 3D. 3D it's 10. Before that, let's just see the other thing also. Num1 and let's say how many. Let's say 1 comma 2. Okay, and num1 is 1D array, so you can't have a extra column. Yeah, so num2 is 3 and this is 10. This part of the 3D array I'll just explain to you in 1 minute. Just wait, let's go back here. So when I say 1 comma 1 comma 0, as I've mentioned here, 1 comma 1 comma 0, right? There are two interfaces, two 2D arrays, right? This is a 2D array with value of 0 with index 0, right? Like here red was 0 and green is 1, assume. Okay, so this is 0 index and this is 1 index of that 2D array, right? Now in that 2D array, this is a 2D array again. Are understanding? So here when I say x is equal to 1 again, 1 comma 1, 1 means the second row, right? This is the second row. But like in computer language, you always index from 0 to 1. It starts from 0. So this is the first row, this is the second row. And 1 comma 1 comma 0. 1 is this is the second 2D array. In that second 2D array, this is the second row. In that second row, this is the first column 0. So we return 10. That's how we return 10 here, right? Now for slicing. Yesterday we saw slicing. Slicing basically returns a subarray. Yeah, for num3, it returns 285. This is basically I've done it by using this. This basically returns the all the what is it row column part, whatever is in the column part, and here it's basically like x comma y, right? So this is rows and columns in slice or indexing or slicing. You basically tell it as num3 and you basically tell rows comma columns. That is how you basically index or slice in NP arrays, right? Now let's use step function also. As yesterday we mentioned, the step is nothing but start, stop, and step function will basically increment every time. So here I'm telling for numpy array 0, sorry, for the index 0, start from the index 0, start from what am I talking, for the row 0, for the row 0, start from 0th element, right? 0th element of the column, and then the end element will be 3 of the column. These both are columns. This is the column place. Yeah, and then I'm stepping with 2, which means it increments at 2, right? So first at column 0 and row 0 it was 1, and column 0, sorry, row 0 and column 2 it will be 3, right? So it returns array 1 comma 3 and with the data type 16 as well. And this is how 3D array will actually look. As you have seen above, we have mentioned 3D. 3D array will consist of array of 2D arrays, as I've told you earlier. 1, 2, 3, 4, 5, 6. This is a 2D array. And 7, 8, 9, 10, 11, 12. This is a 2D array. These 2D arrays is also a 2D array only. Yeah, as you can see, this is an these brackets literally symbolizes that this is an array of 2D arrays. Right. Now, how do we assign data types? Data types we actually use, above we have actually mentioned d type for our num3 array. We've used d type is equal to int16, which allocates 16 bits for each elements of that array, right? So that is the data type. Int16 is a data type, integers, and at 6 value 16, right? So now let's actually, this is the default pattern in which NP numpy arrays are assigned data types, right? I is for integer, B is for boolean, U is for unsigned integer, F is for float, C is for complex float, M is for the time delta, and M is for date time, and so on, as you can see. So now I'll just type into string numpy array 1 2 3 4 5 1 2 3 4. Even though I'm passing it as 1 2 3 integers, as I'm mentioning the data type S4, which is string with 4 bytes, 4 bits, right? So it'll give me buffered with 1, buffered 2, buffered 3, buffer 4, which is all our strings, right? This is how you will assign data types, right? Yeah. So let's just move on to copy versus view, right? So let's make a new array. Array is equal to np dot array and pass in 1 comma 2 comma 3 as usual. We are basic. Yeah. X is equal to array dot copy, and then let's make y is equal to array dot view. This is basically a comparison between dot copy and dot views, which are the methods in the operations in NP arrays, right? Yeah. And now let's just print x and print y. Okay. And then let's actually try to change the array element. Okay, array of 0. Let's make it 69, and then let's try to print x. Let's try to print y, and let's also try to print the array which we have changed. As you can see in the first step, the copy array x is a array dot copy actually makes a copy of the original array, right? Like in every, let's say control C, you have control C a code, and it's in your memory, right? Now even though if you change your code, and you can always paste it, right? That is why you use dot copy method. Dot copy actually stores in the copy of the original array here, and it stores in here. So 1 2 3, and here I've printed x, so 1 2 3 again. And now dot view is basically your actual whatever array looks like now, right, at the present moment. That's the dot view operation, right? Dot view command or operation, you can tell it. So now it's 1 2 3, and now print y will give you the actual current values of the array, which is 16 and 2, and then also when we printed the array, which is 16 and 2 3. Now what will happen if you print it again? If you print it again, everything will change. Yeah, so it's basically the same thing. Yeah. Now let's go to array reshape. Yeah, an array reshape. Let's just try to print the actual array, the array that we made up here. Let's actually yeah. So I've actually increased the length of the array by adding in some extra elements. Now let's just dimension of the array. So let's print the shape of the array. As you can see, the dimension is 1, shape is 3. Yeah, shape is 12. As you can see, it was not loaded previously. Sorry. Yeah. So basically, now the array has 12 elements, and the dimension of the array is 1D array, right? Now with the reshape function, I can change this 1D array into any type of array. Let's just try for 3D arrays directly, because that's kind of difficult. Let's say z is equal to, not difficult, it's actually different. Yeah. Dot reshape 2 comma 3 comma 2, right? And now let's try to print z. As you can see, this has returned as a 3D array, right? Here two interfaces, sorry, two 2D arrays. So we get two here, three rows, 1 2 3, 3 rows and two columns, right? Another thing you need to notice, sorry, keep in mind is that the multiplication of these three should always result to the total result to the shape of this thing, right? So here 2 into 3 will give 6, 6 into 2 will give, sorry, 3 into 2 will give 6, 6 into 2 will give 12. So it should be always equal. If it is not equal, you cannot make an array, right? Because you should only make an array with the elements here, right? Proper elements. Yeah, so what will happen, even if I give it like this, it will work. It basically means two 2D arrays with 2 rows and 3 columns. This will work. But then if I tell I want to make 3 rows and 3 columns, it won't work. As you can see, an array cannot reshape size 12 into this thing, because when you try to reshape this, it'll be 2 into 3 6, 6 into 3 16. We don't have 16 elements, so we can't reshape. So that's a easy hint to do this thing, to do the reshaping part. Now let's move on to the iteration in arrays. Yeah, so for 1D array, you just use for loops. For x in let's say array, I'll just print x. As you can see, I've traversed to the array and I've printed x. Now for iterating through 2D arrays, like what we will do, we'll use two for loops for x in array, and for y in x, print y. Yeah, so this is a 1D array, and that's why we have a problem. Let's just take num3. Num3 is our 2D array, as before we have mentioned it. Yeah, so we're able to traverse the 2D array and we're able to iterate through a 2D array, right? Great. Now let's try to iterate through the 3D array. For x in num 3D, y in x, for y in x, for z in y, print. As you can see, we're able to traverse the 3D array as well. Now, instead of writing these three loops, which will obviously increment your time complexity, make into of n cube of n cube. So we just use nd iter, np.nd iter. This is a built-in function or operation that is an numpy module library, which allows you to iterate through elements in an array, irrespective of their dimension, right? So let's just do this thing. That is okay. Let's just as we're running short of time, let's just go with the enumerate. Enumerate will also basically enumerate your n-dimensional array. As you can see here, it has enumerated our three-dimensional array with 0 0 0 as an index, 0 0 1 and 0 0 2. With these are the first row elements. With this, the second row elements complete of the 2D array, and then it goes to the 3D array, right? Yeah. So and then we come to the joining of arrays part. This is where in the beginning we try to concatenate two arrays which is to concatenate two numpy arrays, right? And we are not able to do it because the SIMD, right? So now let's concatenate two things, which for that you will just use np.concatenate. Here you will use array 1 comma array 2, then np.concatenate. I'll try to print it, and will basically return the concatenated array of array 1 and array 2. Now the same thing goes for joining two arrays, right? Yeah, for joining two arrays, you just use the same thing. Array is equal to np.concatenate 1 comma arr 2 comma access equal to 1. Um, yeah, so it has basically concatenated our 2D array with access 0, right? So here it has taken 1, 2, 3, 4 and 5, 6. It has basically taken this as an array and it has concatenated. Let's try access 1. Yeah, so when you use access 1, it basically takes in the two first element, which, sorry, the first arrays. What am I talking? The first, yeah, first arrays, the first rows of the 2D array, and it puts them into the same array, same row. So 1, 2 and 5, 6, which is the first row in array 1, and 5, 6, which is the first row in array 2, which is concatenated, and we get it here. Same way you can actually use a stack. This is the vertical stack. In stack you can have vertical stack, horizontal stack, and normal stack as well with axis. Yeah, so this is a basic implementation of stacks. And then we'll do splitting in arrays, right? Splitting in arrays is also same thing. Like let's say here 12 numbers are there, right? 12 numbers are there in this array called numbers, right? When we do np.array split and we pass in the arrays, right? And then we should just use the how many parts we want to split the numbers, right? Like we mentioned 5, so we'll get 5 parts of the numbers, right? And one more thing to note is that here it will automatically split into equal parts, right? You won't find duplicates in any other part. Like we have 12 elements, and we need to get 5 parts out of the 12 elements. So what is the natural process? We just divided by 5. So each thing will have 2 2, but still we'll have 2 remainders, right? Right. So we just add one to array, another to another array. You will always get equal. You will always get mentioned array number, right? That is the splitting in arrays. Now let's do searching in arrays, right? Searching in array is also the same thing. Basically, here I use np.var to do searching. np.var, and I'm trying to search if array %l2 is equal to 0. I'm returning it. It will take inside the x value variable, and I'm printing it. And np.sort search sorted. What will this do? This will basically sort the array. Right here, it is not sorted. It will sort the array, and it will check for the value, right, 2, for the value 2, and will return the index, right? That is the difference between np searching and np sorted. Yeah, so basically here we are using np.var. It'll check wherever this condition is there, it will pass in here. Suppose if our array is let's say 8, it'll give you two elements, right? And then here we this thing doesn't sort it. np dot var doesn't sort, so we get 1 comma 2. As you can see, 0 1 2, 2 is at index 1 and 8 is at index 2, so we get those things. Whereas index search sorted will sort this array, sort this array, and let's say I want 8. It'll be at, yeah. So what if I want 1? It'll search sort it and it'll give me 1, right? That is what search sort will do. And then sorting in arrays, right? So num random number dot I'm making this is also an np operation, sorry, np functionality, where we use random variable, sorry, what am I talking, random module, right? So here I'm making an array of size 10, right? And I'm populating with random values of 1 to 59, and I'm using a random int so that it gives me only integers, right? So first I populate the array using random values of 1 to 10, sorry, for 10, and I populated with random values of 1 to 58, and this is populated. Now for sorting, basically I just use np.sort, right? What np.sort, as I said earlier also, it uses timsort plus complexity, and this is what the sorted array will look like, right? So next we'll come to filtering an array, right? In filtering an array, it basically is used for filter the array purpose. Like, yeah, so I'm passing here 1 for 41, 42, 43, and 44, and here in next array I'm passing true false, right? So when I run this, it'll map with the this like a new array, and I'm passing it with array of x, right, for this element, right? So here it will combine with this. If 41 is true, then it will pass inside the new array, and it will check 42 is false, so it won't pass. 43 is true, it will pass in. 44 is obviously false, so it won't pass in. That's why you get 41 and 43. Yeah, so this was the filtering in array, and this is the basic. This is basically all the operations in NP NumPy. Apart from this, there is other functions such as even normal functions, all the distributions, every other functions that you will have to look it up by yourself. So this was the NumPy and OOPS session. We conclude OOPS and NumPy from the session. From tomorrow, you will be learning pandas and diving into the actual field of data science and machine learning. So good luck with that. Any doubts, you guys? And also you'll be having a quiz, like a graded quiz regarding these topics. So be prepared for OOPS and NumPy in the coming days. It may be a surprise quiz, or you'll have it scheduled. We'll let you know about it. So this was basically about NumPy and OOPS concept. Yeah, if you don't have any doubts, I'll be closing the session. It seems that you guys don't have any doubts, so I'll be closing the session. Thank you guys for having me.